Grandmaster, and I'm actually a developer for Hydrogen Torch, which is one of our two deep learning platforms. A bit embarrassed to say that I'm based in Singapore. I'm Singaporean, but this is my first time in India. Very happy to be here. First time in Bangalore. Very excited to get a chance to speak to you. Over the next half an hour, I'll be speaking and introducing to you two of our core deep learning platforms. The first is Hydrogen Torch. The second is Genie. Now, I can't do full justice to these two platforms in half an hour. Oftentimes, you're asked to go for workshops where we will be given a day or two to cover these two platforms. So what I'd like you to do is just keep an open mind. In one sentence, these two platforms are platforms that allow you to build, train, and deploy deep learning models, and more importantly, from a business perspective, to solve problems around unstructured data. Unstructured data in the form of text, images, audio, and speech. So what I'd like you to do, right, as I go through my presentation, is think about the types of data that you deal with in your business units or professionally. Perhaps you're dealing with text information. Perhaps you're dealing with images mainly. Or what I've been working on recently is speech. Maybe you're dealing with speech data, and a common use case I've been hearing from clients and prospects is call centers. Right? If you're dealing with call center data, this is the platform for you. So just keep an open mind. And of course, throughout the rest of the day, happy to engage with you. Deep learning is a very deep field. Yeah, I really can't do justice to it in half an hour, so just keep an open mind. Agenda-wise, very straightforward. I'll be walking you through these two platforms, Hydrogen Torch, Genie, with some use cases that I've been working on. Okay, so let's start with Hydrogen Torch. The first of the two platforms. This is the platform that allows you to build, train, and deploy deep learning models. And very, very simply, the first thing that allows you to do is unlock the value of unstructured data, right? So we do have an ecosystem of platforms, for example, driverless, that's primarily for tabular data. Hydrogen Torch is really focused on unstructured data, and I'm going to keep on hammering on it. Text, images, videos, audio, speech. It's a one-stop shop. What I personally like to frame it as a universal deep learning platform. The second, and this incorporates the team of Kaggle Grandmasters, including myself, spread globally. In fact, the previous speaker, Pascal, I'm working with him on this as well. And we have Grandmasters across the globe working on this platform. So you do have the benefit of building state-of-the-art deep learning models. And third, but not the least, is deep learning technical frameworks are one thing, but we help you use these platforms, use these techniques to innovate, and then to actually solve business problems. So that's something that we're mindful of. Okay, so how it works, I think this is pretty straightforward for anyone that's dealt with a machine learning or deep learning platform. As you bring your data, right, whether it's in the form of text, images, audio, or speech, you select the problem type, and I'll go through the types of problems that you can solve with this in a slide. Let Hydrogen Torch train the model. Oh, and the other thing I should mention is that we just released a new version of Hydrogen Torch over the weekend. In fact, we are at version 1.3. And we are expanding the feature set, so it's no longer just training models, but we do allow you to deploy off-the-shelf pre-trained zero-shot models for a subset of the problem types. So the key one that I've been working on is speech recognition. In many cases, you don't want to train a speech recognition model. You just want to do transcription. Hydrogen Torch allows you to do that. And the third, again, and this is something that you can't forget, it's nice to have trained the model, but you need to be able to use it, right? And we offer you multiple ways of deploying the model to production. 3 ways. The first is you can continue to use it within the GUI, as I'll show you in a bit. The second, for the more technical audience, you can download the trained model as Python binaries and write your own Python code around it for deployment. And the third and really robust way is that we do have an MLOps platform. And the cool thing, again, another new feature that we've just released in version 1.3 this week is that within the GUI, you can directly deploy trained models to production to our MLOps platform, and then treat it as an endpoint where you can send requests and get predictions. So I think something that we are very conscious of is that training is all fine and good, but in many cases, you're interested in just getting something working, right? Having pre-trained models. So this is something that we continuously improving on. So who is it designed for? And this is something I think that very core, something that we've thought about, because when we talk about deep learning, even if you're a deep learning guy, maybe an NLP guy, when it comes to computer vision, right, maybe NLP guys, you won't have much understanding of computer vision. Computer vision guy, you might not understand NLP. So we really spend a lot of time trying to cater to a wide audience, ranging all the way from junior data scientists, even business analysts, all the way to experienced deep learning engineers and data scientists. So if you're on the junior side, and you'll see this in a bit, we have a no-code GUI platform where a business analyst can run inferencing, can import data, can train models. You can gain experience and master deep learning. And as a deep learning practitioner myself, the architecture is what state-of-the-art changes day to day. And we'll update the platform to keep it state-of-the-art. Now, on the other extreme, if you're an experienced deep learning engineer, part of a team, and I think across this morning, I had a chance to speak to some of you. A lot of you are already very technical. We want to cater to you. And here, I guess, we have we sometimes mention Kaggle. We sometimes mention Kaggle Grandmasters without really discussing what that means to us. So Kaggle is a competition platform. And our company, I'm very happy as a Kaggle Grandmaster myself, is we tend to value Kaggle and practitioners that have Kaggle experience very highly. In fact, this platform labeled Genie, many of our other platforms in our ecosystem, are built and designed by Kaggle Grandmasters. And what that means concretely is that the Grandmasters use their competition experience, their professional experience, and then imbue and incorporate the best deep learning methods and algorithms. And that's related to the next few points where, you probably heard of hyperparameter optimization or searching for optimal model parameters. We surface it within the platforms for you. Okay, key differentiators. I like to focus on the second one, problem type. So I really like to emphasize the fact that it's a universal framework that covers all the domains I've been mentioning. What I've encountered in the past is that even as a technical person, you might find a commercial or open source framework that's good at one thing. Maybe it's good at NLP. Maybe it's good at computer vision. But it's very rare that you find a framework that covers across the domains, as you'll see in the next slide, I believe. So that's something I think we're very proud of, and something that leverages the skills of the Kaggle Grandmasters. For example, over the past half year, I've been focusing on audio and speech deep learning. I have a colleague in Japan who's also a Kaggle Grandmaster, master of computer vision. For the latest release, we've added the ability to perform training on 3D images, and that's especially relevant to medical imagery. Okay, this is probably the most important or most relevant to you, right? So again, I'm really rushing through in half an hour. So what I'd like you to think about in your professional capacity is think about the kinds of data that you have access to. So for example, if you have text or images or audio and speech. And to be clear, these are the supported problem types within Hydrogen Torch. As a basis, across all the domains, we support classification and regression. But for the individual domains, we support the specialized problem types that are relevant to them. So for example, for text, you'll see token classification. For the NLP folks in the audience, you can think of that. An example of that would be named entity recognition. For span prediction, question-answer models. For sequence-to-sequence models, text summarization models. And for metric learning, you can think of it as search or ranking models. And under images and video, and you have classification regression, but we support object detection and the various image segmentation problem types. And as I just mentioned, this week in the latest release, we've added the ability to do 3D semantic segmentation. For audio and speech, these are my babies. I've been working on them over the past year. Speech recognition. And you'll see in the use case I'll go through, there's been a lot of movement in speech recognition. And that's true for all the domains. So that's, I think, the other differentiator is that, yes, we support these problem types. Yes, there are frameworks out there that support problem types, but we keep it bleeding edge, right? So that's our promise to you, which is we don't just support the problem types. The underlying architectures, the underlying techniques, we will always keep it up to date with what's state of the art. Okay, for an actual use case, and this is something really cool that I've been working with an organization in Singapore. In one sentence, the problem is they're interested in monitoring radio communications between aircraft and air traffic control, or folks at the airport. And what they want is, given the radio speech, and this is an example of a transcript from a radio communication, they want to extract the airline entity. So this is an example of I believe an interaction between an American aircraft and air traffic control. So the input is speech, to be honest. Here I'm just showing the transcript. What they want to extract is the airline Delta 2846. Okay, I've talked enough. Let's actually go through the actual platform. And this is the landing page. In fact, if you recall from the previous presentation that Pascal gave about LLM Studio, it's using a common UI so that folks using this and LLM Studio will have very easy time transitioning. So this is the landing page. And you'll just see some information about the environment it's running on. It's running on our cloud. And it's running with a single GPU. So deep learning, you need GPUs, single Tesla T4. For the more technical folks among you, our training capabilities parallelize across GPUs, both across experiments and within experiments as well. And to orientate you to the UI very briefly, the three key navigation areas would be data sets, where you would import data sets, experiments. Experiments are basically a model training run, where you would train a model or deploy a model, a pre-trained model, against a data set that you've imported. And last but not least, once you train a model, you want to run predictions, you would do it there. So again, I want to emphasize rolling out to production, you can continue to use the web app. You can download it, or you can export it to MLOps. So I'm going to jump out of order to show you the performance of a speech recognition model that required no training, and hopefully the audio will play. So what you'll see here are actually individual predictions of radio communications, and I hope when I press play, you guys can hear and follow along. So I'll press play, and then under here is the actual prediction of the transcription.
JetBlue 62, Palm Beach Tower, runway 28 right, line up and wait, traffic 6 mile final. Line up and wait, 28 right, JetBlue 62. JetBlue 62, runway 28 right, clear for takeoff. Takeoff 28 right, JetBlue 62. JetBlue 62, contact departure. JetBlue 62, Palm Beach Tower, roger. JetBlue 62, say intentions.
And we'd like to come back to the field. We're going to go ahead and fly this head, go out over the water, and plan for come back into two-way right.
Okay, so maybe you might have dealt with speech in the past, or you might not have. As a speech practitioner, this level of accuracy wasn't possible, I would say, up till a year ago, right? So, I mean, as a technical guy, I was quite shocked because given the static, given the graininess of the audio, to be able to predict at this level, it's quite crazy. And to be clear, in this case, we are deploying an off-the-shelf model, so it's quite cool. A couple other things I should mention for our speech capabilities. This is English, but we do have multilingual capabilities. I don't speak Hindi, but I've had my Indian colleagues try out Hindi, and they tell me it's good. Happy to demo Hindi to you if there's ever a use case. So again, this is an out there example. I just think it's really cool. But I think from a business perspective, there's a lot of interest from a call center perspective. And I just want to emphasize that it supports multiple languages. So if you go back to in order, let's go through data sets. So you'll be able to import using a host of connectors, AWS, direct upload, Azure, etc. And once you've uploaded a data set, you can inspect it. And this is actually another use case where we're interested in satellite images. Right, so these are satellite images, and the use case is they want to detect the buildings. So each picture is a sample, and if you hover over it, you can see the areas that are highlighted. Those are the labels for the buildings, right? So import a data set, you can inspect them. I have a whole bunch of speech ones because I've been working on them. Of course, the next thing to do once you've imported a data set is you want to train a model against it. And there's a lot of technical information here, but notice the key thing that we have right top is we have this setting called experience level. And this is how we cater to a wide audience, which is depending on your experience level, whether you're more on the junior side or business analyst side, you can pick novice, or if you're a deeply technical practitioner, you can pick master. And depending on what knob you pick, we basically surface different parameters. So if you're an AI guy, we show stuff like the image size, number of channels, normalization techniques, and of course, I think one of the more important ones would be the backbone, the underlying architecture, right? So that's one way we help you. The other is this grid search. Again, the more technical folks will probably understand, which is this helps you to optimize the parameters. We offer two options. One, which is you can define your own custom grid, or for every problem type, we have some automatic default settings which do a search, right? So this might be intimidating, but the takeaway here is that we've really tried to minimize, especially if you're more on the junior side, the amount of fiddling you have to do to let you really hit the ground running and then run an experiment. And then I'm not going to train an experiment live, but this is a trained model of the satellite image problem type. And okay, what you see here, if I can get my mouse working, are predictions from the model on data that it's not seen. So again, these, to be clear about the problem, it's to detect buildings in images, satellite images. So you can see from the highlighting, and to be clear, these are validation samples. So these are samples that the model has not been trained with. So you can see that it's actually performing very well. And across problem types, we will have explainability and interpretive relevant metrics for them. So we really try to make it turnkey as much as possible. And then finally, as I shown briefly, you can run inferencing. So again, at a very high level, take a step back. Hydrogen Torch, it's a platform that allows you to import data, to train deep learning models against them, and then to make predictions against them. And what I've found personally, I think helpful from a client perspective is always happy to engage you. If you have a use case, you might not even know that you have a use case. Happy to speak to you. Just let us know what kind of data that you have access to, and then we can see how we can help you. And I think one thing that's very important that we feel very strongly about, that's why we built this platform, is that while it is good to have zero-shot models, in many cases, even if they're good pre-trained models, you need to do fine-tuning. In fact, you can also think of this platform as a platform for fine-tuning. Us being in Asia, right, a lot of the pre-trained models that come out open source are mainly geared towards Western users, right? So for example, for speech, what I encountered with our users in Singapore is it works very well for that American example, but let's say you want to deal even with English, but Singaporean accented English, you might need to further train the model, right? So this is where we add value to you, for you, especially in the Indian context. You're dealing with different languages, different dialects, different accents across problem types. This is the way that we can really help you. So happy to engage with you across the rest of the day to explore the possibilities. So that was a lot of information. Hydrogen Torch, again, to re-emphasize, it's a platform that allows you to unlock the value of your unstructured data. And what works hand in hand with this, as we've encountered, is that, so to train a model, you need labeled data. And this is a pain point. It's not sexy. You need to get people to annotate data. And we built a sibling tool called Label Genie. And Label Genie, as the name implies, is a platform that allows you to annotate data, which you can then directly import to Hydrogen Torch and train a model. Yep, and very simply, it's not just annotating, but we want to accelerate the process because it's a very labor-intensive process. Imagine, especially for images or speech, you have to get people to, laboriously go through sample by sample. So the first thing, broadly, is that we allow you to create labeled data sets. The second, which is equally, or if not even more important, is that we provide zero-shot models that sort of pre-annotate the data, which you can then have your annotators verify, or if not, if they agree with it, they can really just skip through and then quickly go through. And the third, as I mentioned, it's a sibling product to Hydrogen Torch. In fact, it's part of a broader ecosystem of our H2O products. you can export the annotated data sets and then directly run training models with Hydrogen Torch. And let's go through label Genie. And if you haven't noticed, we have a common design thinking, yellow and black. And I think the landing page shows exactly what it does, right? The keywords are zero shot, annotate, collaborate, and then train within Hydrogen Torch. So same thing. In this case, you'll be importing an unlabeled data set. Let's tie it back to the air traffic control problem. So in this case, you use Hydrogen Torch to run the transcription to get the text predictions of the speech model. Here, you would create an annotation task where you want to label the aircraft entities right? So we start with the unlabeled data. And then in this case, this is a transcript. So again, think about this as the prediction of the output from the model I showed you earlier. And in this case, this is communication and Liberty Tower United 2860, blah, blah, blah. You would have your annotators annotated. And we tried to make it as easy as possible. This is another version that we just released this week. So it's very good timing for you to do hands-on. For both Hydrogen Torch and Label Genie, we had new releases to our environments this week with new features. Here, the main one you can see here is the JKU. Those are keyboard shortcuts, right? Because if you're annotating a lot of samples, keyboard shortcuts are a lot quicker than clicking through. Now, from a zero-shot perspective, I have one example that's really cool. And we had a user, I believe in Japan, that was more interested in traffic or road-related use cases. So in this case, I've had uploaded this toy data set, which are basically images, unlabeled images of road signs and traffic lights. And here the goal would be to create an object detection data set. So you want to draw bounding boxes around the traffic lights or road signs. So I want to emphasize here that in the data set, it's not labeled, okay? And where the zero-shot stuff comes in is you would pick object detection. And at this stage, the labels that you give, these are the signals of the zero-shot model to try to make a pre-annotation. So here I'll type road sign. And the underlying zero-shot model would be using that information to try to make a prediction. And I'll just jump to already started example. And let's actually go to annotate. And okay, in this case, there's some turnaround time. But basically, what would happen in production is that it would come pre-annotated with bounding boxes around the signs. So these two platforms work hand in hand, Label Genie and Hydrogen Torch. And I think the takeaway, just given the half an hour I have with you, is that we are hoping to create a one-stop shop for you to solve problems around unstructured data, whether it's in the form of text, images, audio, and speech. And as I think the other thing we've encountered is that even if a problem type isn't supported right now, there have been cases where clients or prospects raise potential use cases to us, and we are very happy to add it, especially if it's a more universal or generalizable use case. So I'm going to stop here. Very happy to speak to you, and very happy to engage with you on your use cases as well. Thank you.